Okay, to continue the work we did in the previous notes, we're going to look at distributive property with more than two terms. So in 3.4, we looked at multiplying binomials only, and today we're going to add to that. The actual work is the same though. As you can see, we're still using the distributive property. We are just going to be doing it more. And as always, check for like terms after multiplying. Just make sure you get everything in the first polynomial multiplied by everything in the second. So for example 1a, we're going to find this product. And these might look complicated, but just start small. Just know we're going to start with the first term in the first one times the first term in the second one. 8x times 2x squared is 16x to the third, right? 1 plus 2 is 3 for the exponent. And then move on. 8x times negative 6x is negative 48x squared. And 8x times negative 3 is negative 24x. Now let's move on to the second term. It's a negative 5. So negative 5 times 2x is negative 10x squared, I didn't say. Negative 5 times negative 6x is positive 30x. And negative 5 times negative 3 is positive 15. Now our list of numbers is getting kind of big there, but just remember you've got two terms times three terms, so you should have 6 terms in your initial result, which we do, 1, 2, 3, 4, 5, 6. Now we just combine like terms. So first check for like terms. We have 16x cubed. That's the only x cubed term, so that stays the way it is. Negative 48x squared minus 10x squared, that's negative 58x squared. Just combine the coefficients. Negative 24x plus 30x is 6x, and then that plus 15 at the end. So there's our first result. Okay, so same process as 3.4, just a few more terms in our problem, but really the work hasn't changed, the process hasn't changed, just the amount. Let's go on to example B. Same idea, so negative 5x times 7x is negative 35x squared. Negative 5x times 11x squared is negative 55x to the third. This one wasn't written in standard form, so we'll have to rearrange when we simplify, but that's okay. Negative 5x times negative 3 is positive 15x. All right, next term, it's a 1, so that's kind of nice. These all stay the same. So plus 7x plus 11x squared and minus 3. 1 doesn't change anything. All right, now we can combine like terms. So start with the highest degree. I like to do that. Negative 55x cubed. That's going to go first. And it was the only one. Now the x squared terms, negative 35 plus 11 is going to be negative 24x squared. 15x plus 7x is 22x. And then minus 3. Again, double check when you do these to make sure you end up with the right amount of terms. We have 2 terms times 3 terms. That gives us 1, 2, 3, 4, 5, 6 terms. Should get 6 before you simplify. If you have a binomial times a trinomial. All right, example C, the trinomials first. That's okay, you can do it the same way. Start with 2k to the third. We're going to multiply by 2. That's 4k to the third. And then 2k cubed times negative k squared is negative 2k to the fifth. And because the trinomial is written first, we're going to just use that one. We could go backwards and do the binomial first, but this is fine. So negative k squared, negative 9k squared times 2 is negative 18k squared. Negative 9k squared times negative k squared is positive 9k to the fourth. And then we'll go to our third term here. Negative 11k times 2 is negative 22k. And negative 11k times negative k squared is positive 11k to the third. And now we combine like terms. So scan through, look for the highest exponent. It's right here, negative 2k to the fifth. There's no other k to the fifth power, so that is going to stay the way it is. Now we have k to the fourth. Again, it's the only one. So we're going to write that next. We have our plus 9k to the fourth. Okay, now we do have 2k to the third, 4 and 11, so that's a plus 15k to the third. Keep scanning through. Negative 18k squared is next. And then minus 22k. So this one we ended up with 5 terms in our final answer because only 2 of them were like terms, the 4k cubed and the 11k cubed. The rest just stayed the way they were. Definitely possible. You never know what's going to happen, but just follow the rules and multiply and then see what happens when you simplify afterwards. All right, now there is a difference we can see when you multiply a sum and difference. We can talk about another pattern here. It's when you multiply 2 binomials that have essentially the same numbers inside them, but one says plus and one says minus. And you end up with this a squared minus b squared thing. And we'll look at why. If you don't want to memorize the pattern, you can just do the math, and you'll see how it works out. So x times x here is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. And 4 times negative 4 is negative 16. And so you can see here when we combine like terms, the negative 4x and the positive 4x completely cancel out. Negative 4 plus 4 is 0. So we end up here with just x squared minus 16. So the reason why this happens is this positive and negative, they make those middle 2 terms cancel out because they are identical. They're both 4x, but one's positive and one's negative. And this will always happen if you have the same 2 numbers or same 2 terms, but one has a plus and one has a minus. Those middle 2 terms will cancel out. And so you can just square the first and second, square a, square b. But if you don't want to trust that you're doing the pattern correctly, don't worry about it. Just do the math, and it's okay. So we know, using the pattern, that we'll get w squared minus 49 for this answer. But let's go ahead and do the math and make sure. So w times w, that's w squared. W times 7 plus 7w. Negative 7 times w is negative 7w. Negative 7 times 7 is negative 49. And you can see that these 2 middle terms will cancel out. And so we end up with w squared minus 49, which is what we predicted. So the pattern does work, but again, if you're not comfortable, you can just do the math and see what happens. We can go ahead and use the pattern on example B though. So 3x times 3x, we know that's 9x squared. Since this is positive and negative, we know that the middle terms, the 18x and the negative 18x, will cancel out. And so we end up with minus 36, and that's good. So the pattern does work, and it can help you save some time. But if you aren't sure or don't want to use it, you can just multiply as normal. You'll get the same answer either way. Last example here, let's go ahead and find the area of this rectangle using what we know about polynomials. So remember, area of a rectangle is length times width Now this rectangle, we don't know the numbers, but we know the length is 4x plus 1 and the width is 5x. So we're just going to multiply 5x times 4x plus 1. And since we don't know any numbers and we don't have a total that the area is equal to, we're just going to simplify 20x squared plus 5x. And that's the area of that rectangle, given the information we know. If we knew it was equal to some total, we could potentially figure it out, but we can't, so that's as far as we can go. All right, so just remember, use the distributive property. Make sure that you multiply carefully so that your exponents are correct, and then just simplify by combining like terms.